Good morning, good afternoon, and good evening, everyone. This webinar is being brought to you today by DLT and Parasoft. Hello, my name is Jim Fitzmaurice, and I manage the Application Lifecycle DevSecOps practice here at DLT, a tech data company. In this webinar, you'll learn how to approach security test automation for both greenfield and legacy development, key opportunities to consider when getting started, as well as how to adopt streamlined developer-centric security workflows to ensure security at speed is a reality for your DevOps pipeline. Before we get started, I'd like to give a brief overview of Parasoft. Parasoft provides innovative tools that automate time-consuming testing tasks and provide management with intelligent analytics necessary to focus on what matters. Parasoft technologies reduce the time, effort, and cost of delivering secure, reliable, and compliant software by integrating static and runtime analysis, unit functional and API testing, and service virtualization. Parasoft supports software organizations as they develop and deploy applications in the embedded, enterprise, and IoT markets. With developer testing tools, manager reporting analytics, and executive dashboarding, Parasoft enables organizations to succeed in today's most strategic development initiatives: Agile, continuous testing, DevOps, DevSecOps, and security. If you have any questions during this presentation, we ask that you submit them into the chat box in the WebEx, and we'll review and answer them at the end of the webinar during our Q&A session. Our presenter today is Mark Lambert, Vice President of Products at Parasoft. With that, I'd like to turn things over to Mark to get things started.
Thank you very much, Jim, and thanks for that great introduction. Welcome, everybody, and I'm really looking forward to today's conversation, kind of talking about how you can shift left your DevOps strategy and really ensure you have a secure DevOps pipeline. But before we jump into the details of the implementation and the shift left practices, it's important to think about what are our drivers behind our development activities and our development project. These are all in support of your agency's missions. And really, these do directly intersect with the kinds of challenges that we see within the public sector as well. Whether you're focusing on accelerating your delivery to your end customer, the warfighter, or other parts of the agencies. You're trying to accelerate it. You're looking to remove the bottlenecks of your process, and testing, which is what we're going to focus on today, is one of those key bottlenecks that you really need to identify how you can efficiently eliminate that. If we're talking about quality, ensuring that you're delivering accurate and reliable applications that can scale to meet the needs of the warfighter. You're looking at how you can improve the efficiencies of your development process while maintaining your delivery requirements, meeting within your budgets, within defined budgets or budgets that get redefined as you're going through the project initiatives. And then last but not least, focused on risk and reducing the risks that your application or your delivered application brings to the organization. Now, security is obviously the #1 risk here, and especially when we're talking about leaking of sensitive information with the associated negative outcomes that can come from that. Now, security is also the #1 risk that most of our public sector clients are also trying to avoid. The challenge is that all of these different business goals are somewhat interrelated. If you want to accelerate your deliverables, you don't want to accelerate the deliverables with increasing costs or increased risk or poor quality. So you have to figure out how you can balance all of these things together and how you can do them efficiently, so obviously you can get all of the green arrows rather than getting a red one pointing in the wrong direction. So as I said, today we're going to focus on security, and we're going to focus on how organizations can implement a secure DevOps pipeline. And we're going to talk about different overall testing techniques which help improve the quality and the reliability. We're also going to talk about how we can bake security into the pipeline from the beginning of the process. And as I said, security is the #1 concern within public sector organizations. We see a lot of regulation in the industries, PCI for payment credit cards, GDPR for our European friends, SOX compliance, HIPAA for healthcare, are all focused on protecting information and making sure that we have a secure application in place that is not going to leak sensitive information. And more regulation is coming. California, New Jersey, this year also initiated regulation around privacy data as well. But we're constantly hearing about security breaches in the public sector. Equifax was a big one a year or so ago, where they were breached. Pretty much everybody's social security number is out there. I don't know about you. I just presume that my identity has the potential to be stolen, so I have monitoring services to identify if I'm actually being, if my identity is being reused by somebody unintentionally. But the breaches are still happening. So whatever we're doing today is fundamentally not working as part of our development process. These breaches are becoming more and more frequent. We're actually not hearing about all of them. So you'll hear about them in an annual report where somebody will kind of mention it as a footnote way after when they've actually figured out how to patch it and recover from the problem. So what we have to do is we have to think about, well, what is it that we're doing today? Why isn't it working? And what should we be doing to change that? So what many people do today, and unfortunately this is still the situation in many organizations. I'm going to reference the SANS Institute report in a little while, their 2018 report, Secure DevOps, Fact or Fiction. In that report, they identify that many organizations are still relying on an end of cycle security process, basically trying to bolt security in at the end of the process. You have a number of challenges with this. The first challenge is you have a finite number of people and technologies that you can leverage at that later stage of the process. That's your first problem. Specialized skills, software, and actually getting access to humans, people that can understand what the security problems are and uncover them, is actually very difficult. Very scarce resources in almost every organization. So what happens is your security team become a gate saying, hey, there's some problems, you need to fix these. The trouble is the development team are usually challenged at that point. They've moved on from whatever it was that you're developing, whatever it is that you're testing there at the end of the process. They don't understand the problem. You're trying to educate the development team on a security issue by giving them a security vector through your application, and they have difficulty being able to map that to actually what the problem is in their code. And often when you're talking about something which is just doing end of cycle scanning of a code base, you're going to get lots of arguments about false positives. Even when the teams do fix something, now your integration teams have to retest the whole thing because security has such a global impact. The problem here is that what you end up with is you either end up with delayed releases, or what is more common is you actually end up with security issues leaking out into a production environment with a promise to fix them at some point in the future. And again, this is the same kind of information that the SANS Institute's report identified. What I propose is the best thing to do is, rather than starting or rather than putting security at the end, let's start with security from the beginning. Let's define our development policies. Let's define how the code should be constructed. Let's define what the workflow should look like, the testing practices that should be leveraged to ensure that I create not just a secure application, but also a reliable application that's of high quality. This gives us the ability to apply our security practices throughout the development process, leveraging our different teams to perform different types of testing practice and contribute towards delivering a secure application. And then when ultimately a security vulnerability is found, because you're not going to capture everything, certainly not on the first cycle through, when that security problem is found, you can then improve your security policy to identify second and subsequent and resolve so that you don't introduce any new defects or security vulnerabilities into the process. You can also leverage the testing practices that the teams are already doing to provide information and traceability to make it easier for the development teams and the QA teams to identify the root causes associated with those security vulnerabilities. Now, that's all great. It's going to give us the ability to apply a developer-centric workflow. It's going to help us really kind of go back to the policy itself. But what do I do and how do I make this work? What are the techniques and how can we build a secure DevOps pipeline that not just is, as I said before, is going to support secure code, but also bake quality into the application as well to ensure that I can deliver high quality and secure applications quickly. This all kind of bakes into numerous techniques as we go through our DevOps pipeline. There are typically different phases to the development process. People draw them differently depending on who you're talking to. What we've done here is we've actually pulled out particular sectors for what's referred to as the scaled agile framework. Very popular in organizations that are trying to scale their agile testing practices across an enterprise or across the organization as a whole beyond individual siloed teams. What that scaled agile framework does is it identifies these different phases that you go through as part of your development process and clearly identifies components or techniques, should I say, that are leveraged during different sectors of that process. Now you'll notice here that I've labeled out specific testing techniques as we go through it. What you want to be able to do is to execute these continuously as part of your DevOps pipeline and execute them continuously, leveraging infrastructure that can be stood up dynamically, that itself is secure and assembled in a secure way. And this is really where containerization, the use of Kubernetes to orchestrate containers, it really gives us a very flexible and powerful way of ensuring that we have a secure software factory from the start. So if I dig through these, and I'm going to go through this reasonably quickly, these slides will be available after today's presentation, as well as we're more than happy to kind of do some more one-on-one sessions through the DLT team as well, and we'll give you some more information about how to get in touch with the team at the end of today's webinar. So a development process always starts with defining the work items, the things that we're going to be doing, whether you call them requirements, stories, backlogs, or maybe defects or PRs, FRs, whatever the terminology is that you use. There is a thing that defines a unit of work. That unit of work is defined in some system of record. For example, Jira, very popular within Agile communities, version 1 or TeamForge from CollabNet, 2 other technologies from one of our partners that we partner with. We integrate within this ecosystem with each of these as well as many others as well. So you might even actually have your own proprietary system that defines that work item. The bottom line is once you've defined the work item, the development teams start doing the development. And as part of the development process, the first area where we can start to build security and quality into the application is through the use of code analysis. Now, I'm not talking about simple code beautification or making sure that the code looks nicely formatted, it's easily readable. These things are important. But what I'm talking about here are the deep reliability and security issues that are hidden within the code base that you need to leverage technology that can really uncover those. Now, there's a lot of open source technology out there which will get you started. There's things like SonarQube, for example. But when you start looking at trying to uncover those deep reliability and security issues, that's when you're going to need to look to go beyond open source. This is where the Parasoft products of JTest, C++ test, and .test provide this level of analysis for Java, C and C++, and .NET technologies. Now, it's not just focusing on specific issues. What you really do need to do is you need to say, okay, there's a whole bunch of problems that I can have within my code base. Where do I start? How do I identify what things I should be checking for? So, for example, our C++ test product has well over 4,000 different rules within it, all mapped to different standards to make your life easy when you want to be able to align to an industry standard. And there are really two sets of industry guidelines, those orientated around secure code development. Typically OWASP and CWE are the most popular guidelines that people reference, identifying the things that you need to protect yourself from. And then CERT is more of an engineering standard that gives me the ability to say, okay, don't do these specific things in the code. With the Parasoft technology, we have our checkers aligned to all three of these standards, giving you the ability to very quickly create compliance reporting that we may get to see a little bit towards the end of today's session. The second area is all around reliability, and really this is critical within embedded systems, projects like the Joint Strike Fighter, leveraging derivations of MISRA to actually rolling that into the Joint Strike Fighter Zone standard. These are standards which help ensure that you're delivering reliable code and that it's going to do the right thing. These are, as I said, very critical within safety critical industries. F-35 is one of those projects which often we reference within that world. Now, code analysis actually has two uses, and it really has the ability to detect, but more importantly and more valuably, prevent. So often when you're running code analysis, you'll get beaten up on a false positive type of conversation. Well, that's not really a problem. The point of these standards that we were referencing a moment ago is that they become prescriptive to help you identify catalysts to the problems that can help prevent the defects from being introduced in the first place. So the graph that we have here on the right-hand side talks about how defects are introduced during the early phases of the software development process, but they're identified during the later stages as we start assembling the application and as we start doing more UI-centric testing practices. But as we all know, the cost to repair those is significantly more. Cost and complexity of trying to debug the problem, cost of impact of the change, cost of the number of resources that are then involved in trying to diagnose where the problem is and remediate it. What we're focused on at Parasoft is shifting that curve left so you can identify these defects much earlier in the process. And everything we're going to talk about today is going to identify that. But more importantly, what static analysis can do when done the right way can help reduce the number of defects introduced in the first place. So find them sooner and reduce them to, in essence, accelerate your development process. Now, still within the develop part of the process, we can then start looking at unit testing or TDD, test-driven development practices. Here, what we're going to be wanting to do is to leverage where possible open source frameworks. So JUnit for Java, for example, is where our JTest product comes in, enabling us to be able to help Java development teams easily create JUnit tests. When you're talking about C and C++ development, you may be looking at Google Test. It's an open source framework for C++ development. There are some toolings out there that support that. We support that with our C++ test product, but our C++ test product also has its own proprietary unit testing framework within it, targeted at testing embedded devices. So there's a lot of usability focus there. That foundation of unit tests really gives you an ability to ensure that your code is well designed. So often we see within the public sector, organizations focused on code coverage and saying, okay, what's my code coverage? I need to increase that number. They're basically the amount of code that was exercised. That's actually the wrong thing to do. You don't want to just focus on the code coverage metric. You want to have the practice early on in the process, not saying, well, I'm at 10% today, I need to be at 100%, and trying to retroactively fit a code coverage number in. If you start proactively and start with unit testing from the beginning, you'll have better designed code. It'll be easier to maintain. It'll actually also be easier to debug and ultimately test as well. Now, the unit tests themselves, it is really the fundamental layer to what's referred to as the testing pyramid. This is very popular in agile development communities. In essence, unit tests are quick to diagnose, quick to execute, and they can be integrated, as I said, right from the beginning. So it's the ultimate shift left test automation component. And then, as I said, you're going to want to track code coverage number, but that's not the only number. You want to understand how the tests correlate back to the original work items, so you can understand what your test coverage is or your requirements coverage, how much of your underlying capabilities are actually being tested and validated. Now, as we start moving further to the right, we move into end-to-end testing, where I have an assembled application and I can start testing different components of it, seeing how they work together. I then deploy to some kind of stage environment, and I can also do verification in production as well, if that's appropriate for your project. Each of these leverage the same underlying techniques. So functional test automation, now I'm talking about testing at the API level, REST APIs, web services in some cases, in essence, programmatic or protocol message level testing that gives me the way of being able to test my application without having to invoke all of the use cases through the user interface. Then as we move up the pyramid, we start looking at user interface testing, typically driven through the use of Selenium for web applications. And then actually at the top of the pyramid, we have a very small amount of manual testing. The purpose of the pyramid is to organize your portfolio of test automation. You should have a lot of unit tests backed up by as many as possible API tests that are testing your business logic without the requirement for the UI. Then you have your automated UI tests, but it's not a trapezoid, it's a pyramid. You still want to be doing manual testing efforts, but you want to minimize those because they're, in essence, the most inefficient, or should I say, the most expensive type of testing to do. And you want to reserve that type of testing for the use cases that really require much more human intuition and that are not as repetitive as the tests that can be automated. So when you look at the automated UI tests, you're typically talking about, as I said, Selenium. We have a product called Selenic, which actually helps organizations that are using Selenium address maintainability and stability issues associated with UI tests, which is typically the #1 challenge that most people face when they're doing their UI testing. As we move down the testing pyramid, as I said before, increasing our functional coverage with the API or service level testing, and this is where Parasoft SOA test comes in. This is our industry-leading API testing technology that has been in the market for a little over 15 years, really providing a human interface onto a programmatic application layer. those API tests really represent a very valuable sweet spot. Not only are they a very efficient way of automating the validation of my business logic, they're a very efficient way for me to communicate between my test and my dev roles in the team. They're easier to diagnose, but I can also leverage them for non-functional testing as well. So this is where you can leverage these types of tests for doing validation of performance with shift-left performance testing, and also for penetration testing, giving you the ability to be able to validate the security layer of the application at a functional level. Now, as I do these non-functional testing requirements, or validate these non-functional requirements, the challenge becomes that my test environment probably can't support that type of activity. So when I'm doing performance testing, for example, maybe I don't have access to the right data or systems with the correct performance characteristics. When I'm doing penetration testing, I want to protect my external dependencies from potentially getting attack vectors populating all the way through. I also may want to be able to control the way my external system is being compromised. This is where a technique called service virtualization comes in. This has been very popular within the public sector, as I said before, focused around shift-left performance testing, really helping organizations do early-stage performance testing as part of their agile delivery process. But it has numerous applications, because what you're doing now is you're simulating the behavior of the dependency rather than having to stand up the full environment. Because even within the world where we have Dockerized or containerized backend components, maybe I can't stand it up in the correct state that I need because I have data dependencies, I have timing constraints that I'm wanting to control. And this is where the product Parasoft Virtualize comes in. Now, all of these techniques are giving me a lot of quality information. They're giving me a lot of data that I now need to somehow parse so that I can make some decisions about my application. And this is where we want to start aggregating this data into a centralized view of quality. And this is where our reporting and analytics dashboard comes in. Aggregating data from each of these testing practices and activities, bringing compliance reporting in place for standards such as CWE, OWASP, CERT, as well as the reliability standards such as MISRA and AutoZAR for embedded device development, and bringing all of that into one central location where I can not only get the insight, but where I can start to cross-correlate this back to my original work items, which is where we started right from the beginning. So here, by triaging the data that's coming into the reporting and analytics system, I can then review the data, identify defects or issues that are within my application delivery, and then create additional work items for the team to work on and resolve. I can also aggregate data in the system and associate with the work items, and then also send the data back to the original system of record. This provides me true bidirectional traceability. So I have a full view of my quality initiatives. I have a full view of my DevOps process, and I can aggregate all of these different quality and security practices into one place. So these are the techniques that you leverage. We talked about what the problem was at a high level. We talked about the different techniques and practices that we can apply to build security and quality into the pipeline. But this is all kind of great. There's a lot of pieces, but how do you deploy this so that you can adopt secure DevOps, and how can you make this successful within your organization? Now, I referenced this earlier. The SANS Institute in 2018, actually right at the end of 2018, if I'm remembering correctly, released their Secure DevOps Fact or Fiction report. this is a great report. It's available through a number of different sources. Leverage Google, you'll find it. A few key findings that which really resonated with me when I was looking at this data. Less than half of the respondents have shifted left their security initiatives. So this is what we talked about right at the beginning of today's presentation, in that many organizations are still taking a right-sided approach to security, looking at security just before we release. And a little bit over 50% of the respondents still waiting to engage their information security resources until later in the stages of the development. That's a resource constraint. Waiting to engage those security resources probably means that they're not ready. They're not ready to receive the information, but they're also not ready to be part of the process. And this is not very agile. However, you're waiting for your security resources at the end or the later stages of the development process. However, 65% of respondents said that the corrective actions are in the hands of the developers, meaning your resolution to the problem is right at the beginning, but you're identifying the problem right at the end. And the most common top challenge within the report was the shortage of application security personnel and skills. So this is re-emphasizing the point that we made at the beginning of the webinar today, which is you really have to approach security at the beginning. But there's a last missing piece that really resonated with me, is the piece of visibility. If the management doesn't understand or recognize the need to address security risks, the team won't be given it looks like I missed a word there, the something and resources they require. These are actually all direct quotes from the report. So the point here is, if you don't have visibility and if you don't have it early, you're going to be stuck perpetually in this problem of firefighting the development process. So let's break these down into 3 key challenges, and then let's quickly go through how we can solve them. The first is the one of limited resources, limited skills within the organization. End of cycle security testing, resulting in delays and vulnerabilities in production. If I'm finding at the end, but I injected it at the beginning, it's a highly disruptive process change for the team. And then lastly, the unknown state of security risk until the last moment. If I'm not able to give my management team the visibility that we have a problem and that we need to address the security issues, then they're not going to find out about it until the end. And that's not going to help you improve the process and accelerate your deliverables. It's going to increase your cost. It's going to reduce your time to market. It's going to affect your security risk. And it's also you're going to have to compromise. You're going to have to remove some of the capabilities from your desired deliverable to meet the objectives of the project. So let's dig through these. Let's talk about the first one. Let's talk about how we can reduce or address the knowledge gap in the team. Now, Parasoft has, as I've been talking about, a variety of tools and technologies covering the entire DevOps process. I am going to focus right now on a workflow as it relates specifically to static code analysis. However, the same types of workflows apply for other types of testing practices and techniques as well. So the first thing within our workflow, you can see a few key elements. We have developers, we have an architect or a lead, we have a couple of infrastructure pieces, we have some source control and a CI build process that's powered through something like a Jenkins, for example. So where we're going to start here is we're going to start by defining the security policy. And this is where we leverage our industry standards such as CERT, CWE, or OWASP. And we use these as the starting point. So many folks on the call may be familiar with DSSSTIG. DSSSTIG underwent a few changes over the last few years, and went from being a specific standard to follow, do these particular coding guidelines, to actually deferring security guidelines to OWASP and CWE. So really, this is probably the area where you're probably going to end up focusing on using these industry guidelines as a starting point. How that looks within the Parasoft solution is that we have a series of pre-built test configurations that have those guidelines enabled. We then have our checkers aligned to the different guidelines, requirements, or rules within the standard to make it very easy for you to identify which checkers need to be enabled. And then we have severities associated with them as well to help you even further refine. We can also create new rules, and we have a framework where if you have your own standards or your own design patterns that you want to put into place and enforce, we can also extend the rule set to help with that as well. So here, by having the ability to leverage those industry standards and by leveraging our automatic pre-mapped checkers to those, it's very quick for you to be able to enable the team. Now, what I didn't show just there, and I will show this in a few moments when I talk about IDE workflows, is that all of those rules have documentation associated with them, which includes examples of a vulnerability, an example of how to repair, as well as links to training materials that helps educate the resources as well. This gives us the ability to enable the developers to become the front line for security. Now, you're going to still leverage your security team to define what those standards are, audit to make sure that the standards are being applied, and also applying the sophisticated security tools that are already in place to uncover your second and subsequent issues that you can then, or your exceptional situations that you can then apply new checkers to improve and identify those second and subsequent. That test configuration becomes the thing that is our framework for ensuring that we can accelerate the process. Because the next step now is to say, how can I avoid the process where I'm applying these checks right at the end? I want to move them earlier in the process. So we're going to go back to our workflow diagram here. Notice that each of my developers have different IDEs. So Parasoft, we support Eclipse, IntelliJ, both typically Java developers, Eclipse and Visual Studio, typically your C or C++ developers. A lot of embedded systems like Texas Instruments, for example, leverage Eclipse as their primary IDE framework. And then we're able to share that test configuration directly to the developers, where they're able to execute that test configuration locally on their machine, either from within the IDE or from within the command line as well. So there are many organizations, especially within advanced C and C++ development, where the development team are leveraging command line tools and not leveraging IDEs as the development framework. By being able to support both of these use cases, we're able to enable the entire team, but more importantly, multiple teams within the organization that are leveraging the technologies in different ways. Now, the testing is not just done on the developer's desktop, though, because the code goes into source control, and then you have a secondary process that runs post-commit that's running as part of your CI/CD pipeline. The purpose of this process is to really behave as a gate or a trust but verify process to make sure that nothing slips through. So you're going to want the developers to do early stage work in their IDEs, try and catch as many things as possible before they check into source control, and then use the CI/CD process to run that sanity check to capture anything that's potentially missed, but also do a more holistic analysis of the code base or more holistic application of your testing practices to cover not just the area that the developer was working on, but making sure that they haven't negatively impacted the rest of the application. So a couple of examples of how this looks. I'm actually using JTest and our Java engine here as an example. So from within the IDE, I can actually select what configuration that I want to use. It could be pre-configured based upon an industry standard, or it could be one that the team have defined based upon their specific organizational requirements. Then when I execute that, I get results within the IDE, both here in the bottom left, where I'm able to navigate the particular violations, looking at how that code violation appears in the code through highlighting of paths through the code base, as well as navigatable views, being able to look at the underlying details of the code. I can then also select an individual violation and look at the documentation associated with that. That gives me an overview of what the violation is relating to, particular CWE in this case. It includes examples and repairs, and it also includes links to additional materials, including educational resources. Now, all of these elements can be applied from within the IDE, but we also want to be able to do that trust but verify process. So this is where we plug directly into the CI/CD pipeline, being executed as part of a Jenkins workflow or pipeline, for example, and performing the analysis on the entire code base. There are plugins available for the different CI platforms that give me the ability to be able to populate that data directly into the CI pipeline. So I have data in my desktop, I have data in my pipeline, and in a few moments, you'll see we have data within the reporting and analytics dashboard as well. So what I've done here is I've enabled the developers to perform analysis directly inside their IDE or locally from their command line locally on their machine, as well as leveraging that same command line process to be able to integrate directly into my CI. So I have a framework in place now where I've got a set of rules, a set of checkers that are being applied that have embedded training and documentation. I've made it available to my development team so they can execute it and use it early. But what's the state of security? How do I get the visibility as to what's going on within my process? And how can I ensure that I'm not finding out bad news right at the end of the process? So let's go back to our workflow diagram. And this, obviously, at this point, probably, is that the CI/CD process is what drives the data for the centralized reporting. That data is aggregated within dashboards and sent back to the developer's desktop so that they can actually take the results from the analysis of the entire process as part of our integration with CI/CD and leverage that locally within their IDE as if they just run it on their desktop. So the dashboards give me the ability to be able to aggregate data together. Here, what we're doing is we're looking at an example OWASP dashboard for our .NET technology. The same applies for C++, Java, as well as the other standards as well. The dashboards are highly configurable, so I can actually integrate data from security as well as other testing practices. So for example, here, as I bring in an example of one of my live dashboards, we can see here that I'm integrating data from my original work items. Here in this example, it's version 1. I've got security data on the right-hand side, both CWE and OWASP. I've got broader static analysis violation data, as well as test data, including coverage. All of that in one centralized location gives me the ability to get a centralized view of quality. But when I'm looking specifically around a compliance against the standard, I can actually go into the details of understanding how I'm doing against those specific set of guidelines. I can look to see what deviations I've identified. I can see where my violations, I can see my compliance level. And I can also generate PDF reporting, which can be used for offline auditing purposes. They can be used for communications with other departments. Now, I said that data is all there for reporting, but it also makes its way into the developer's IDE. So now, rather than running locally, I would actually import the violations from the reporting and analytics dashboard. And then those violations would be imported into the IDE and appear as if I just executed them locally. So all of the same workflows that I was talking about a moment ago apply for the downloaded data as well. So here we've addressed the third issue. So we now know what's going on from the point of view of security. I can also cross-correlate that with my overall quality process and use this to give me the ability to make proactive corrective actions rather than waiting until the 11th hour or just before pre-production before I run into those kind of problems or having to make the hard decisions. So the workflow, just to reiterate that again for a moment, the test configurations are used to define where do I start? What is my starting point? Where, from the point of view of aligning with the particular industry standard, I can then expand upon that with my own custom rules or bringing in other quality-driven checkers into the process. I can then execute those locally on the developer's machine, either through their IDE or through a desktop command line. Then the code is checked into source control, and we do a full analysis of the code base, going beyond just the work that the local developer has done, gives us our safety net, gives us the ability to make sure that everything is covered. And then we provide a high-level manager view that gives us the ability to be able to see what's going on, but also work with the violations within that dashboard and send those back to the developers for remediation on their local machines. So I hope this has been a useful conversation for you guys today. In summary, there's a few key elements of what I've been talking about today. So the workflows that I've just been talking about are available on-premise as well as for deployment within the cloud. They are highly configurable to meet your requirements. They are, as I said, designed for both on-premise and cloud, meaning the code or all of the analysis stays within your network. It doesn't go outside. It doesn't go to a Parasoft cloud service to be for processing. It's all within your infrastructure and your managed control. The next is hopefully you've heard me say this a few times. I talk about security and quality in the same breath. These are two sides to the same coin. You can't test quality into an application and you can't test security into an application. You have to build them in with the right practices that we talked about at the beginning of today's session. And then lastly, real-time compliance reports to avoid late bad news. You want to find out bad news early. It gives you the ability to do corrective actions. It gives you the ability to reset expectations. And that is much better way of managing the team. So if you'd like to get some more information, I've put a couple of resources here. We have a pretty extensive YouTube channel that we are proactively adding more and more content to at the moment. We also have a blog which is filled to the brim with information on varieties of different testing topics. The URL here will specifically jump you to the blogs that have been written strictly around security. However, the blog covers everything from functional test automation all the way down to unit testing and security as well. Of course, if you'd like to get more information, please feel free to reach out to Parasoft or the DLT team. And I know that we've got a number of other webinars that are coming up over the Q1 to Q2 timeframe. So if you would like to kind of attend that, please feel free to go ahead and hit this URL and join the VIP DevSecOps list. So with that being said, Jim, I'll hand it back to you.
Mark, thank you very much. Really appreciate your time today. One quick thing I want to make everyone aware of that is on the webinar is we have added a handout, a PDF that Parasoft provided about their DevSecOps and their technology. So I wanted to make everyone aware of that. You should be able to look at that and download that if you're interested. Additionally, Mark, we have a couple questions that were submitted to us. One being, and I'll cover this one because I have the answer. Someone asked about the slide deck being available to the participants today. Yes, we will be sharing that with everyone that has attended today, so you will get that. Additionally, if you have any other questions, please feel free to type them into the chat box. But Mark, we have a couple questions here that I wanted to ask you from the audience. How is testing different in agile software development?
That's a very loaded question. So I'm going to give you my super simple answer. There's just a lot more of it. Now, the thing with agile, obviously, as everybody's aware, is the iterations are frequent and they're short, which means that you don't have a lot of time. So the fundamental thing is when it comes to agile testing, you have to adopt a test automation strategy. You have to adopt an automated quality strategy, and that's exactly the kind of the blueprint that we laid out today, focusing on the testing pyramid, focusing on test automation. Now, here's the thing. So your test automation is going to help you. You're going to get a lot of the repetitive tasks out of the way. But as you build more and more tests, they take longer and longer to run. So you also need to start looking at how you can optimize that test execution by focusing on the things that are changing through the iterations. Now at Parasoft, we have technology that's called test impact analysis, which will analyze what changes have been performed during an iteration and then kind of optimize your test execution of unit tests, API tests, and web UI tests, and optimize those so you're only executing a subset. The reason why you do that is you get quick feedback during kind of your active development, i.e. during the development day. But the key thing is that this is all building on top of an automation strategy. Now, one last thing on this topic. I mentioned this briefly when we were doing the slides. I talked about the testing pyramid. This is a very well understood concept within Agile community. It is the thing that people say that this is how you should test in Agile. It's been promoted by Michael Cohn and Martin Fowler, who are two of the Agile thought leaders in the industry. And the thing that I want to re-emphasize from earlier is that it is a pyramid, not a trapezoid. So you have manual testing, but the point is that you don't have a lot of it. You don't focus on manual testing as your primary testing technique. You focus on doing automation. Automation is good at running quickly. It's also good at doing repetitive tasks that humans are not good at. The things that humans are good at is understanding how something feels, kind of going through UI, UX, customer experience type of workflows, but also there are going to be other workflows that are just very, very difficult to automate. So my point here is you want to do manual testing, but you have to focus it, and you should be always looking at it through the lens of, can I automate this? And if you can automate it and run it all the time. If you can't automate it, then document it and make sure that you understand what work items it relates to so that you can use the traceability reporting to identify which manual test scenarios need to be validated. This is the only way that you're able to keep up with Agile development practices. Sorry, Jim, I know that was a really long answer and you've got other questions, but it is one of those areas that's kind of a soapbox for me.
Well, the next question that was submitted, actually what you were just talking about dovetails perfectly into this. The question is, who should develop automated tests?
Oh, okay, everybody. It's actually not just the responsibility of the testers. It's actually the responsibility of the team. Within Agile, many organizations have moved to the Scrum methodology. And what happens there is you have very tight integration between your developers and your testers. They're working collaboratively, side by side, step by step. I argue that actually everybody owns quality. And it doesn't mean to say that you don't use testers. That's actually another movement in the industry, which is very dangerous, where they say we don't need testers. We're just going to use developers, and developers going to write all the tests. People are different. We all have different minds. Some of us are much better at trying to do the negative testing. Some of us are much more creative from the point of view of creating something. But ultimately, everybody owns the responsibility. Developers should be creating automated tests for the work that they're developing. And testers should then use those automated tests and expand them to cover additional use cases, kind of think about the data, think about the ways that the thing could be broken. Because if you only have the developer who's written the code writing the test, they're probably going to miss stuff. They're going to be very happy path focused. If you can get them to handle the happy path, you're getting your base foundation. They're therefore building code that has to be testable because they're going to be responsible for doing some of the testing, and then leverage your testers to expand that and cover the corner cases. So again, that's another. These are really good questions. They're kind of talking right to the root cause of it.
All right, we have one final one here, Mark. What kind of tool chain do I need to support automated testing?
Okay, so we touched upon a few pieces. As I went through the slide deck, I kind of was emphasizing open source components. You want to leverage a blend of open source technology and frankly, vendor technology that supports you in that open source world. Now, obviously, Parasoft is a vendor. You have an advantage of leveraging a vendor rather than just leveraging pure open source technology, because ultimately you have somebody to shout at when something doesn't work, when you need it to support a use case, when you've got a new thing a new compiler that's coming, you need to make sure that your existing test technology is going to support that. That's what a vendor can bring to the table. But really what differentiates us at Parasoft is we are kind of an open source first vendor. From the point of view of we try to embrace open source tool chains and build value on top of those. And then where they don't exist, the open source tool frames, then we'll bring technology to bear that's specific to Parasoft's stack. So for example, our Selenium product is built to enable Selenium testers. Our JTest product is built to enable JUnit testers, both of them doing that without any vendor lock into the technology. The thing that is probably worthwhile pointing out as well is that as I went through the blueprint of the different phases and the different techniques that you should leverage, there was a lot there. You don't have to do it all to be successful. You can identify where you want to start. Often many people start with static analysis or code analysis because it's relatively easy to inject into the process. And this is actually an area where the Parasoft team can help as well. So this is where we'll often come into an organization and we'll be asking for a particular component, or they'll be asking for a particular component in the tool chain. And through conversations, we can identify if that's the right place for them to start. You want to ask yourselves, where are you today on the testing pyramid? Is your testing pyramid inverted, or is it a funny shape? Where's kind of the wins that can kind of help me move that forward. So hopefully I answered the question. It was a little vague from the point of view of components, but if I haven't answered the question, please feel free to submit a clarifying question, and I'll be more than happy to go.
Excellent. Well, Mark, thanks again. Everyone, I want to thank you for attending today's webinar. Mark for his thoughtful commentary today, and both the DLT and Parasoft teams for helping to make this webinar happen. Thank you everyone for joining us. Have a great day.